let's go really quick. Did we even finish number 1 yesterday?
Yeah,
Yeah.
we did number 1.
Did we do?
Starting number 2.
We were studying.
Okay, SOHCAHTOA. So stands
He needs
for
3. That's what he meant.
It's 2.
sine of the angle equals opposite over
Uh-huh.
hypotenuse. Cosine equals adjacent over hypotenuse. Guys, I'm going to go a little bit quick. I'm sorry. There's just a lot on this one, and I want to
I have that
through it.
I want to get done.
Yeah.
Donatron.
And this class is like 5 minutes shorter than most classes, so
That is true.
makes it a challenge.
Yeah.
You guys remember what the reciprocal of sine was?
Hypotenuse over opposite.
It's called cosecant.
Cosecant 1 over sine of.
It's equal to 1 over sine, or it's also equal to hypotenuse over opposite. The opposite of cosine, or the reciprocal of cosine, is secant. So that would be like hypotenuse over adjacent. And then tangent goes with cotangent. I'm trying not to stay in the way. It's adjacent over opposite. Hopefully you guys still have all these notes from yesterday. And if they ever tell you to find like what is like a secant of 45 degrees, you would plug in 1 over cosine of 45 in your calculator. Alright, which something like that's going to happen today. So there's a few calculated problems. So we are ready for number 3. We did number 1D.
Yeah.
Okay, on 2 and 3, we've got a little bit of an issue. I don't remember if we talked about this or not, but what's the issue with this triangle?
Missing a number.
Missing a side. So how do I find the missing side?
I don't remember.
X squared plus B squared plus C squared.
Right, Pythagorean theorem. X squared plus 6 squared should equal, the 2 legs squared should add up to the hypotenuse squared.
So then we just,
Okay, so yeah, x squared is 133. So x is what?
X literally be equaling.
Square root of 133. Does that simplify? No. Prime. So that's gonna go right there.
almost 11.
Okay, so it's y and x. Anyway, we need to kind of figure that out first so we can do the rest of the questions. A. So, I don't remember where we left off. I think we did like that table. Yeah, I think you're actually up. So, Xander, what would the sine of x be?
So it'd be square root of 133 over 13.
Right. Because it's opposite over hypotenuse.
Where do you want me to put the paper?
Just on my desk is fine. There's a couple other tests right here. Yeah. Opposite over hypotenuse. Caleb, what's the next question? What would the cosine of y be?
So adjacent over hypotenuse would be 130 square root 133 over 13.
Right. Adjacent to y over hypotenuse. If it was upside down, do you guys know what we would have to do?
What?
Well, you can't leave square root in the denominator.
So
So
you
you,
have to multiply.
if you have a calculator, you can do it. It's not really that hard. You just multiply by square root of 133 on top and bottom. So that would change it to 13 square root of 133 over 133. If this reduced 13 and 133, you'd have to reduce it. Okay, that didn't happen, but later on it will. Can't leave a square root in the bottom. If you have a nice calculator, you can fix it automatically. Alright, let's go. Brianna, what would the tangent of x be? Tangent is opposite over adjacent. So what's opposite of x? And adjacent. Yes. And then Ava, cosecant.
13 over
let's see. Cosecant would be opposite sine, so instead of opposite over hypotenuse, it's opposite. Why don't?
Oh, wait, it would be 13 over 6?
Are you using the right letters?
I was looking at X, I'm sorry.
Okay, so yeah, instead of opposite over hypotenuse, it's hypotenuse over opposite. So yeah, it's 13 over 6, yes. Yeah, if you look at angle X or angle Y, that changes the answer, so you gotta be careful. Okay, number 5, state 3 basic trig ratios for each acute angle. So it's very, very similar to what we just did. Lots more of the same thing. Just like the last
Sine, cosine, tangent.
of each acute angle, yeah. But just like last time, we're missing a side of the triangle. So x squared plus 16 squared should equal 34 squared. Gosh, so it's a little bit hard for me to do in my head. So it would be x squared equals this. So in the calculator, we'd have to plug in the square root of that. I think this one came out nice. Was it like 30 or something?
Yeah.
Comes out as 30?
Yeah.
Okay. So the angles are P and Q. So they want the 3 basic trig ratios for those angles. So sine, cosine, tangent of P, and sine, cosine, and tangent of Q. All right. Because what would the sine of P be? Opposite over hypotenuse, so it's 16 over 34. All these are divisible by 2, right? So 16 and 34 reduce, if you divide them by 2, to 8 and 17. Because what would the cosine of P be? Right, adjacent, hypotenuse. Divide those by 2, and it's 15 and 17. And then tangent of P, because opposite over adjacent, so opposite is 16 and 30, right. Divided by 2 is 8 and 15. Yeah, if you can reduce the fraction, let's go ahead and reduce it. So, all right, Reagan, sine of Q. Sine is opposite over hypotenuse. So what's opposite of Q and hypotenuse? Yes. And if you divide those by 2, like that. Okay, and then cosine, Reagan, is adjacent and hypotenuse. So what's adjacent and hypotenuse? And you divide those by 2. Remember, your calculators can also reduce if you just plug it in as a fraction. And then tangent is opposite over adjacent. So what's opposite and adjacent? And divide those by 2. Okay, that's it. Now, there actually is a pattern here that will help us cheat a little bit. Do you guys see a pattern?
I don't know.
Okay.
Kind of. Yeah, I don't know what it is.
Sine and cosine of the other angles are the same. You guys see that?
Oh,
Okay.
the tangent.
And then tangent is a reciprocal when you do that. So it's upside down.
That is.
Okay. So if you remember that pattern, you kind of just can do these 3 and then cheat a little bit. Now if you get these 3 wrong, you're in trouble. But yeah, that's the pattern. So I'm going to be cheating a little bit to help scooch along.
Wait, so why didn't we do R?
Okay, you don't do the 90-degree angle doesn't work.
Okay.
The 90-degree angle never works. All right. Number 7 is a calculator. So everybody plug that in the calculator, and let's make sure all the calculators are on the right setting. You're supposed to round it to 4 decimal places. So everybody plug in cosine 12. And if you don't get 0.97, yeah, then your calculator needs to be fixed. because there are other modes that the calculator can be in, and we will have to change to that later, but not today.
So for cosecant, you do 1 over cosine of 30 or sine of 30.
Yeah, cosecant is 1 over sine, yes. 1 over sine of whatever. So on 7, I just wanted you to plug in the calculator, make sure you're getting the same answer, because the calculators sometimes are in the wrong mode, and we have to fix it if it's not. So make sure you get 0.9781 on 7. Okay, you're good? All right, so we are rounding to the 4th decimal place. If you do round wrong, I will take points off, so be a little bit careful on the rounding. This was like 0.97814, I think, or something like that. 4 is not big enough to push the 1 up, so it just stays 1. All right, number 9 says cotangent of 42.83. Now that button is not on our calculator, so what do we need to push? Cotangent.
1 over opus.
1 over, what's tangent is the opposite of that. So, I think I definitely put the SOHCAHTOA on the test. I'm pretty sure I put the cosecant, secant, and cotangent on the test as well. So you need to know that tangent is the opposite of cotangent, or cosecant is the opposite of sine. Secant is the opposite of cosine. So you need to think of some trick to help you remember that. Okay, so if you plug that in, you're probably going to need to close that parentheses or you'll get an error message, I imagine. It's supposed to come out as 1.0788 on your calculator. All right. Number 11. Okay, this, I kind of question whether people use this, but I don't know. I haven't been out there, so who knows. But you guys see what's different about 11?
How's that one dash thing?
Okay, it's not using decimal anymore. It's using, this is called minutes. So this is 82 degrees and 30 minutes. A minute is 1/60th of a degree. So this is the same thing as 82 and yes, 30/60ths of a degree, like a mixed number, 82 and 30/60ths. So it's like 82 and a half, 82.5. But if it doesn't come out like a nice, neat little fraction, you just have to leave it like,
30.
yeah,
Like over
it could,
60.
if it was like 29 over 60, you'd have to just leave it like that. But in this case, you could just plug in, okay, you could plug in sine of 82 and 30/60ths, or you could reduce it to 1/2, or you could change it to 0.5. But this is a mixed number. You could also put a plus right there, that would work as well. 82 and 30/60ths is what you're supposed to plug in. And this one should come out as 0.9914. Mind your way, Brianna. It's usually the Reagan and Brianna's spots are the ones I usually stand in front of. 13. Okay, 13 they added even one more thing.
That's seconds.
That is seconds, good guess, yes. 14 degrees, 20 minutes. And 15 seconds, whoops. Okay, so what are we gonna plug in the calculator? That's kind of the question. Cosine of 14 plus, what was the 20/60th plus, okay, what fraction of an hour is a second? There's 60 seconds in a minute, 60 minutes in an hour.
So
So there's
12,000.
not quite, 60 60s, 60 times 60 is 3,600.
Oh,
So a second is 1/3600th of an hour, or in this case of a degree. So that's, you could plug that in, that would work. You guys got it? So use the 60 denominator for minutes and the 3,600 denominator for seconds. Yeah, that'll do it. And it rounds, let's see. This one rounds to 0.9689.
Yep.
Okay, oh, I just remembered. I'm actually not going to do 15. Let's talk about 16 now. You can just skip 15. So, is everybody with me on 16? You got to look at this.
Yep.
It says 32 degrees and 39 minutes. So, if I were to round that to the nearest degree, 32 degrees and 39 minutes is between 32 degrees and 33 degrees. Do you guys think that's closer to 32 or 33?
33. Right? 'Cause it's
Yeah,
30 minutes.
39 minutes is over half an hour, right? It's over halfway. 30 degrees is halfway, or 30 minutes is halfway. So if it's over half, this is like over 32 and a half, so this is closer to 33 degrees. Okay, for the B, it says change the minutes and seconds thing to decimals. So we're not plugging it into cosine, but it's pretty much the same thing as this. We're just not plugging it into like a cosine or anything. We're just changing it to a decimal. So 32 degrees is worth 32 plus 39 minutes is worth what?
39 over 6.
39 sixtieths plus 41 seconds.
41
Right, over 3,600. And then you just change that to a decimal and round to, guess what? 4 decimal places, yes.
32, 61, Mr. Jordan.
I'm sorry, it's just really big.
Are we trying to do 2 assignments today?
No, just the one. There's just like 4 or 6 answers on all these, so it takes a while. And I'd like to give you guys time to work on it too.
We appreciate it.
As if you're not doing the evens right now.
No, we're not. What are you talking about? I've never done it.
You're a sinner.
I know I am.
I'm just reconfirming. All right.
See, that takes so long. It's 6 answers per question.
Yeah, but there's kind of a fast forward sheet we talked about. Okay, so we got the same problem as earlier. We're missing the hypotenuse. So how do we set it up? 2 squared plus 5 squared equals x squared. So I'm not spending a lot of time on Pythagorean theorem because that's kind of an old deal, but so anyway, we get square root of 29 for the hypotenuse. Now, moving on. Three basic trig ratios for each acute angle. This is what we did earlier. The tricky part is that the square root's going to be in the denominator now. So we want sine of angle A, cosine of angle A, tangent of angle A, sine of angle B, cosine of angle B, tangent of angle B. Okay. Where did we leave off? Did we get back to, I think we made that all the way around. So Xander, what was sine of angle A?
So 5 over 2.
Okay, sine is opposite over hypotenuse.
Oh, I thought it was adjacent. So square root of 29.
Yeah. Okay, the problem is you can't leave square root of 29 on the bottom. Your calculator can probably fix it. I can't remember, Reagan, did yours do it or not? I don't remember. But all you do, it's not a hard fix. You just multiply by square root of 29. So it's just 5 square root of 29 over 29. Okay, so it doesn't,
Wait, you going on a junior trip?
no.
You're
Are
not?
you kidding me?
No, there's some budgetary issues. I can't go.
Who's supposed to read us a bedtime story?
Mr. Rich.
I guess Mr. Frederick.
Yeah, you can do that. Okay, cosine of A.
Sit next to you guys. Makes me feel alone.
He probably has
Oh no,
to.
we'll break into his room.
He has to room with somebody.
He does have room with somebody. He doesn't get room with himself.
Okay,
You don't have to.
cosine of A, Xander.
Um,
Adjacent over hypotenuse.
yeah,
So,
so it's 5 over.
Yep.
Or 2 over square root of 29.
There you go. So 2 over square root of 29, just like the last one, is going to become 2 square root of 29 over 29. And then Xander, tangent of A, opposite over adjacent, opposite.
5 over 2.
Right, now we don't have to fix that one. Okay, do you guys
I do, I remember.
recall how
I
I
already did it all.
how we cheat?
Yes, crisscross.
Crisscross.
And then the tangents are the reciprocals.
Right, tangents are upside down. So cosine of A is going to be the same as sine of B. And tangent of B is tangent of A upside down, reciprocal. Yeah.
If it could, oh, never mind.
All right. 19 is the same thing. All right, so 8, 12, blank. So we're missing a leg here. So it's 8 squared plus x squared equals 12 squared. So then whatever that comes out as, we'd have to square root it, right? 144 minus 64 is 80. Square root of 80 simplifies. Do you guys remember
4
this?
square root of 5.
Yeah. You guys remember this chapter where we had to simplify all these square roots? Oops, I wrote the wrong thing down. Okay. Alright, same as the last time. Sine, cosine, tangent. By the way, there's like 5 of these kinds of questions guaranteed to be on the ACT. I'm not sure if it was 5, but it was close to that. Maybe 4. I don't remember exactly, but they do put a trig on there. Okay, where do we at? Caleb.
Yeah.
Sine of angle L. So sine is opposite and hypotenuse. So what's
Square root, or 4 square root of 5 over 12.
okay? I should have written that over here. So
Yeah.
4 square root of 5, 4 and 12 reduce
Yep.
to 3. So it's
So
square root.
it's square root of 5 over 3.
Right. Okay, cosine of L.
8 over 12, which reduces to,
If you divide those by 4, it's 2 and 3. Okay, tangent of L.
4 square root of 5 over 8.
And the 4 and 8 reduce to a 2 on the bottom. So it's square root of 5 over 2. Alright. And then you guys know how we cheat on this?
Yep.
Sine becomes cosine of the other angle. Okay, now if you forget the trick, you can just do these. I mean, you don't need to know a trick. You can just do sine of M, just like we did sine of L. But I've got no problem with doing this. Okay, here's a problem though. What's
The
square
5 goes on the bottom.
Yeah, if the square root of 5 is on the bottom.
2 square root of 5 over 5.
Yeah, it becomes 2 square root of 5 over 5. Okay. I don't know if you guys noticed, when I did this yesterday with the other class, I dropped it to 23.
Oh.
Because we were running out of time. That's why I knew I had to hurry today. State decimal approximations this time. Okay, this is a little bit different. Very closely related, but a little bit different.
Oh, is it like
Okay, this time we actually know what the angles are, but we don't know what the sides are. By the way, if this angle down here is 71, it's angle F, how do I find angle D?
Well, the one on the right's 90.
this is 90.
And it adds up to 180.
Yes.
So you just add.
Yeah, three angles of a triangle have to add up to 180.
Yep.
180 minus 90 is 90.
Yep.
90 minus 71 is 19. Okay, they still want us to do sine, cosine, and tangent of both angles. However, we don't know the sides right now.
Yeah.
There's a way you can figure it out with trig. We'll do that tomorrow. But we do know the angle, so we just plug it in the calculator, okay? So I'll do, I guess, I'll do it alphabetically. So we're going to do sine of 19 degrees, cosine of 19 degrees, tangent of 19 degrees, and then sine of 71, cosine of 71, tangent of 71. Now this time it's not going to be fractions because I don't know exactly what the sides are. It's going to be the calculator spitting out a decimal. So it's decimal this time. Brianna, you get the easy job. Just plug in these three and like we're still rounding to 4 decimal places. So just do these three over here. 3255.
3256.
3256, okay. And keep going, these three. Okay, uno más. So is Natalie pretty sick, Ava?
I guess,
You should text her now. It's 344 what?
not really.
3.
3443?
Yep.
Okay, now, what was the cheating trick?
So sin is 9455. 3256.
Okay, this one is a little, okay, it's that upside down. So you could do that 1 divided by that, but I mean, it's probably just easier to just go ahead and plug in because all we're doing is this. So just plug in tangent 71.
Which is 2.9042.
2.9042. Okay, got it. Okay, you gonna see those? If I went too fast, you can just ask me to scroll up here. I'm almost done.
One more, right?
One more. State the other 5 trig ratios for each acute angle. Oh, okay. This one is very different, so make sure you're paying attention, Ava. Okay, tangent equals 4. So if tangent equals 4, what's 4 as a fraction? 4. Whoops, 4 over 1. So tangent, remember, tells us the opposite and the adjacent.
Yeah.
So that means whatever the triangle is, the ratio of the, we'll say this is our theta angle. The ratio of the opposite to the adjacent should be 4 to 1. So my picture's not great. That's okay though. Okay, that doesn't mean this side is 4 long, this is 1 long. It just means this side is 4 times bigger than this, basically.
Okay.
But you can pretend like it's the actual size of the triangle. So how do I find this? Right, 4 squared plus 1 squared is 16 plus 1, 17. So it's the square root of 17. Okay, this one is slightly different because we're not doing sine, cosine, tangent of both angles. We're doing all 6 trig ratios of just theta. By the 6 ratios, I mean sine, cosine, tangent, cosecant, secant, cotangent. So it's not going to be exactly the same as this. It'll be slightly different. But it starts off the same. So sine of theta, cosine of theta, and okay, well, tangent of theta, they already told us. I'm going to go ahead and rewrite it in there because It'll help us later. And then, you guys remember what the opposite of sine was?
It was hypotenuse.
Cosecant.
Oh,
The opposite function, I mean the reciprocal function. Okay, reciprocal of cosine was called secant. And the reciprocal of tangent was called, okay, here's the way back in the day I remember this. Tangent and cotangent sound like they go together, right? Okay, these two sound like they go together, and they do. I'll go here. Cosine seems like it should go with cosecant because they both start with the word co, but they don't. And so you just got to remember these two are like backwards of each other.
Just like in the other, like the problem thing too.
Yeah, kind of. These are different things, but yeah. Anyway, I don't know if that actually helps. It helped me way back when, but you got to think it's something to help you remember like these two go together and these two go together. This one's a little bit obvious. Okay, sine. Right, Ava. Ava, what's the sine of theta here? Opposite over hypotenuse.
4 over square 17, so 4 over 17.
Over 17.
Yes.
Okay, and then cosine, adjacent over hypotenuse.
What is that?
Yeah, still you.
1 over 7, square 17.
So it's,
Square 17 over 17.
yeah. Okay. Now, we definitely can cheat on this one because cosecant, secant, and cotangent are just upside down of sine, cosine, and tangent. So what's this upside down? Well, it's kind of a mess, but remember that came from this. So you just flip this one upside down. So it's square 17 over 4. And this one came from this. Square 17 over 1 is just square root of 17.
And then that's 1/4.
4 over 1 flips to 1 over 4. Okay, so it is not the same, notice, as 21, those other problems. Because we're not doing just sine, cosine, tangent.
Me too.
Yeah.
And Kyle has a